Alright, so we did number 1 together in class. So I'm going to go ahead and start with number 2. So for the first 4, we said that these have common bases. So our goal is to get 16 to have the base of 4. So if we start with 4, 4 to the first power is just going to be 4. 4 squared would be 16. So this is perfect. This is what we want. So we're going to change the 16 to 4 squared. And then the left side just stays the same. We have 3 to the 4 to the 3n. Now that our bases are the same, we just cancel out the 4's and set the rest of it equal to each other. So we set our exponents equal. So we have 3n is equal to 2. Then since n is being multiplied by 3, to get it to the other side, we just divide. So we have n is equal to 2/3. Alright, number 3. So we want to get this 25 to look like 5. And we know that 5 squared is 25. So we can just replace the 25 with 5 squared. So our left side stays the same. And we change the 25 to 5 squared. Now that our bases are the same, we can cross off the bases and set our exponents equal to each other. So we have negative 2x minus 1 is equal to 2. So to get x all by itself, we need to add 1 to both sides. We have negative 2x is equal to 3. And then we divide by negative 2. We get x is equal to negative 3/2. Alright, and last one from this section, number 4. The bases are already the same, so we don't even have to do anything. We just cross them out and set the exponents equal. So we have negative 2k is equal to 3 minus k. So to get all the k's together on one side, I'm going to add k to both sides. Now negative 2k plus k is negative 1k, which I'll just put negative k. So that's equal to 3. And then I need to get k all by itself, so I'm going to divide both sides by negative 1. So the negatives cancel out, and I get k is equal to negative 3. Any questions from this first section? Alright, let's go to the second part where we have different bases. So there's no way we can get this 4 to look like a 6. We can't get our bases to be the same. So what we're going to do is take the log of both sides. So we have the log of 6 raised to the b plus 5 is equal to the log of 4. We have to do it to both sides to keep our equation balanced. So now we're going to take our exponent and move it to the front. So we have b plus 5 times the log of 6 is equal to the log of 4. And our goal is to find what b is equal to. So we want that to be all by itself. So since the log of 6 is being multiplied to it, we're going to divide those sides by the log of 6. So it'll cancel out on the left side. And now we need to put this into our calculator. So first I need to find the log of 4, which is 0.602059. And then I'm going to find the log of 6, which is 0.77815. And now I'm going to divide the 2. So I'm dividing these two. And I get 0.7737. Yep. Okay, now to get our b all by itself, we need to subtract 5 from both sides. So we end up with b is equal to negative 4.226. Any questions here? For the homework, it doesn't say what to round it to, but just as long as you have like 2 or 3, and it'll be specific on the quiz that we'll have on this. It'll say like round to 2 decimal places or 3. Okay, let's look at 7. So there's no way we can get these bases to be the same. So what we have to do is take the log of both sides. So we have the log of 16. I'm just going to move this to the front so I don't have to rewrite it again. And then the log of 9. We're going to divide both sides by the log of 16. So it'll cancel out on the left. So we're just left with 4v on the left. And then I'm going to put this into the calculator. So I'm taking the log of 9, which is 0.95424, and then the log of 16, which is 1.20411. And now I divide. And we get 0.79248. And then to get v all by itself, we just need to divide both sides by 4. So we get v is equal to 0.198. Any questions here? All right, number 8. So again, we need to take the log of both sides. So we have the log of 12. I'm going to skip a step and just move this to the front already so I don't have to rewrite it again. And then the log of 78. It's important that you take the log of both sides. Can't forget that. So now, to get k all by itself, we need to divide both sides by the log of 12. And then we put this into the calculator. So the log of 12 is 1.07918. And the log of 78 is 1.89209. And now we divide them. And I get 1.75327 is equal to k minus 5. Now to get k all by itself, we're going to add 5 to both sides. So k is equal to 6.753. So I just got rid of these decimals because I'm only going to round it to the nearest, round it to 3 decimals. Any questions here? All right, 2 more. So looking at 11, we said our goal for these is to get it to be 1 log. We can't do anything until we have 1 log on one side. So what we're going to do is, since we're subtracting, we can condense it into 1 log by dividing. So we have the log of 2x over 4. And then that's equal to 2. Now, we can simplify this into the log. So 2 divided by 4 is just 1/2. So we have the log of x over 2. So I just simplified that. But you'd get the same answer if you don't simplify it right away. And now when we don't have a base that's written, that implies that our base is 10. So now we're going to write it into exponential form. Once we get 1 log, our second step is to rewrite it into exponential form. So we take the base out of the basement, the exponent comes from the other side of the equal sign, and then that's equal to x over 2. So we have 100 is equal to x over 2, and now I'm going to multiply both sides by 2, so it'll cancel out on the right, so I get 200 is equal to x. Any questions here? Alright, last one, number 12. So first things first, we need to get it to be 1 log. Since we're adding, that means we're going to multiply. So we're only going to have 1 log, and we just multiply x plus 10 times 5. So I'm going to simplify what's in our parentheses here. So it's important that we distribute this 5 since it's being multiplied to 2 things. So we have 5x plus 50. So I'm just distributing the 5. And then since we don't have a base that's written, that implies that our base is 10. So putting this into exponential form, we have 10 to the first power is equal to 5x plus 50. 10 to the first power is just 10. So we have 10 is equal to 5x plus 50. Now we want it to be x equals, so what I'm going to do is subtract 50 from both sides. So we get negative 40 is equal to 5x. Then we divide both sides by 5. Negative 40 divided by 5 is negative 8. So negative 8 is equal to x.